Welcome to Astronomy Daily. I'm Anna, and today we'll start with the exciting news of a new interstellar visitor, only the third ever confirmed to be zooming through our solar system. Then we'll explore NASA's SphereX mission, which is creating an all-sky map of the universe, making its data publicly accessible. Next, prepare for a mind-bending story about a self-destructive exoplanet, an astonishing discovery. We'll also dive into the latest revelations from the James Webb Space Telescope, which continues to reshape our view of cosmic history. And finally, we'll uncover a surprising twist: how Earth's very own weather satellites are now helping us study Venus. Let's get started. Our first stop today is an exciting new celestial visitor. Astronomers have just confirmed the discovery of an interstellar object speeding through our solar system. This marks only the third time humanity has detected an object that originated beyond our own stellar neighborhood. The visitor, officially named 3I Atlas by the International Astronomical Union's Minor Planet Center, has been classified as a comet. Its fuzziness, as described by astronomer Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics, suggests it's primarily made of ice rather than rock. While its exact size is still being refined, current estimates place it at roughly 10 to 20 kilometers wide, which would make it the largest interstellar interloper ever detected. However, if it's truly made of ice, it could be smaller since ice reflects more light, making it appear larger. Regardless of its precise dimensions, it poses absolutely no threat to Earth. Richard Moisel, head of planetary defense at the European Space Agency, assures us it will fly deep through our solar system, passing just inside the orbit of Mars without any collision risk. What makes 3I Atlas so fascinating is its incredible speed, zooming along at more than 60 kilometers per second, or about 37 miles per second. This phenomenal velocity means it isn't gravitationally bound by the sun, unlike comets and asteroids that originate from within our solar system. Its trajectory clearly indicates it's from interstellar space and will continue on its journey back out into the galaxy once it passes us. Astronomers theorize that these icy wanderers form around other star systems. As another star passes nearby, its gravitational tug can free these ice balls, sending them rogue into the galaxy. This newly discovered comet is simply one that happens to be passing through our cosmic backyard. The object was initially spotted by the NASA-funded Atlas survey in Hawaii. Professional and amateur astronomers worldwide then joined forces, digging through past telescope data to trace its path back to at least mid-June. It's expected to get brighter and closer to the sun until late October and will remain observable by telescope into next year. To put this discovery into perspective, the first interstellar object, Oumuamua, was detected in 2017. And was so peculiar, it even led some scientists to speculate about alien origins, though this theory has since been largely dismissed. Our second visitor, 2I Borisov, was observed in 2019. Mark Norris, an astronomer at the University of Central Lancashire in the UK, notes that 3I Atlas appears to be moving considerably faster than its two predecessors. While it's currently roughly the distance of Jupiter away from Earth and primarily visible in the southern hemisphere, its presence is incredibly significant. Scientists estimate that as many as 10,000 interstellar objects might be drifting through our solar system at any given time, though most are likely much smaller. This new detection suggests that observatories like the newly online Vera C. Rubin Observatory in Chile could soon be finding these dim interstellar visitors on a monthly basis. Unfortunately, sending a mission to intercept 3I Atlas isn't feasible due to its speed and trajectory. However, these rare visitors offer scientists an unparalleled opportunity to study material from outside our solar system. Imagine if we could detect precursors of life, like amino acids, on such an object. It would give us immense confidence that the conditions for life exist in other star systems across the universe. Moving from interstellar visitors to an ambitious new mission, let's talk about NASA's SphereX telescope. Launched in March and now comfortably settled into low Earth orbit, this new astrophysics space telescope has embarked on an incredible mission to create a comprehensive all-sky map of the universe. What's truly revolutionary is that SphereX, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICE's Explorer, has already begun delivering its sky survey data to a public archive on a weekly basis. This means anyone, from professional astronomers to curious enthusiasts, can access and use this data to unravel the universe's secrets. As Rachel Axon, the lead for the SphereX Science Data Center, puts it, because we're looking at everything in the whole sky, almost every area of astronomy can be addressed by SphereX data. While other missions like NASA's retired WISE telescope also mapped the entire sky, SphereX significantly builds on that legacy. It observes in an astounding 102 infrared wavelengths, a massive leap compared to WISE's 4 wavelength bands. This extensive range allows scientists to use a technique called spectroscopy to identify the unique signatures of specific molecules. The mission's science team will harness this capability to study the distribution of frozen water and organic molecules, often referred to as the building blocks of life across our own Milky Way galaxy. Beyond our cosmic neighborhood, SphereX data will be crucial for understanding the physics that drove the universe's rapid expansion after the Big Bang. It will also measure the amount of light emitted by all galaxies over cosmic time. The decision to make this data publicly available so quickly, within 60 days of collection, is a testament to NASA's commitment to open science, transparency, and efficiency. It empowers the entire astronomy community to explore and make discoveries that the SphereX team alone couldn't possibly achieve. During its 2-year primary mission, SphereX will survey the entire sky twice a year, ultimately compiling 4 complete all-sky maps. After the 1-year mark, a full map covering all 102 wavelengths will be released. The impact of SphereX extends even further as its data can be combined with observations from other groundbreaking missions. Imagine refining exoplanet parameters collected by NASA's TESS, identifying fascinating new targets for the James Webb Space Telescope, or studying the properties of dark matter and dark energy alongside the European Space Agency's Euclid mission and NASA's Nancy Grace Roman Space Telescope. The possibilities are truly boundless. As Vandana Desai, RSS science lead, wisely states, people are going to use the data in all kinds of ways that we can't imagine. It's an exciting time when the universe is becoming more accessible than ever, thanks to missions like SphereX paving the way for unprecedented discoveries. From the vast universe to individual planetary systems, our next story takes us to a truly bizarre discovery, an exoplanet that seems to be actively contributing to its own demise. Astronomers have found a doomed planet, officially named HIP 522b, which is clinging so tightly to its parent star that it's triggering explosive outbursts and, in turn, destroying itself. This is a completely new phenomenon in our understanding of celestial bodies. HIP 522b is a young extrasolar planet orbiting an equally young star, HIP 522, which is only about 17 million years old. To put that into perspective, our sun is a middle-aged 4.6 billion years old. The exoplanet's orbit is incredibly tight, completing a full year in just 1 Earth week. Since the first exoplanets were discovered in the mid-1990s, scientists have wondered if a planet could orbit close enough to impact its star's magnetic fields. With over 5,000 exoplanet discoveries since then, the answer remained elusive, until now. Ekaterina Eileen, the team leader from the Netherlands Institute for Radio Astronomy, expressed her excitement and curiosity, stating that they had never seen a system like HIP 522b before, especially one with such a young planet orbiting so closely. She added that she had a million questions, because the details of this new phenomenon are still unclear. The team first identified HIP 522b while using NASA's Transiting Exoplanet Survey Satellite, or TESS, which is designed to hunt for exoplanets and survey flaring stars. TESS picked up some intriguing characteristics, prompting a follow-up investigation with the European Space Agency's Characterizing Exoplanet Satellite, or CHEOPS. With CHEOPS, they observed even more flares, with almost all of them directed towards Earth as the planet passed in front of its star. What they discovered was remarkable. The stellar flares thrown out by HIP 522 occur precisely when its clingy planet transits, or passes in front of, the star. This strongly suggests that the flares are triggered by the planet itself. The leading theory is that HIP 522b is so close to its star that it exerts a significant magnetic influence. As the planet whips around, it gathers energy, which is then redirected as waves rippling down the star's magnetic field lines. When one of these waves hits the stellar surface, it triggers a massive flare. Ilin explained that the waves seem to be setting off explosions that are, in essence, waiting to happen, resulting in flares with much higher energy than the waves themselves. This groundbreaking finding provides the first hard evidence that planets can indeed influence the behavior of their stars. And for HIP 67522b, this influence is disastrous. The induced flares are directed right back at the planet, bombarding it with approximately 6 times the radiation a planet at this orbital distance would typically experience. Currently, HIP 67522b is about the size of Jupiter, but its density is incredibly low, comparable to candy floss. This intense radiation bombardment is stripping away the planet's wispy outer layers, causing it to lose what little mass it possesses. Over the next 100 million years, scientists predict that HIP 67522b could shrink from its current Jupiter-like size to something closer to Neptune. The full extent of the damage from these self-inflicted flares is still uncertain, but this bizarre celestial dance is opening up entirely new avenues for understanding star-planet interactions and planetary evolution. Next up, let's take a look at an anniversary of sorts. Since July 2022, NASA's James Webb Space Telescope has been diligently focused on unlocking the universe's secrets, and it has absolutely delivered. With its unparalleled ability to detect and analyze invisible infrared light, Webb has made observations once thought impossible, profoundly changing our view of the cosmos, from the most distant galaxies to the familiar corners of our own solar system. Webb was built with the promise of revolutionizing astronomy and rewriting the textbooks, and by any measure, it has far exceeded those lofty expectations. In just 3 years of science operations, Webb has completed more than 860 scientific programs, collecting nearly 550 terabytes of data, and leading to over 1,600 research papers. The sheer volume of intriguing results and new questions it has raised is truly astonishing. One of Webb's primary missions was to observe cosmic dawn, the period during the universe's first billion years when the earliest stars and galaxies were forming. What scientists expected to see were a few faint nascent galaxies, mere hints of what would eventually become the grand structures we see today. Instead, Webb revealed surprisingly bright and mature galaxies that developed within a mere 300 million years of the Big Bang. It also found galaxies with black holes that seem far too massive for their age, and even an infant Milky Way-type galaxy that existed when the universe was only 600 million years old. This suggests that the universe evolved significantly faster than we previously thought. Adding to the surprises, Webb has unveiled a new type of galaxy, a distant population of mysteriously compact, bright red galaxies, affectionately dubbed little red dots. What makes them so bright and red? Are they illuminated by dense groupings of unusually brilliant stars, by gas spiraling into a supermassive black hole, or perhaps both? And what eventually happened to them? These little red dots appeared around 600 million years after the Big Bang and rapidly declined in number less than a billion years later, leaving astronomers eager to understand their evolution. Webb's observations are also providing critical insights into one of astronomy's most perplexing dilemmas, the Hubble tension. This refers to the frustrating problem where different methods of calculating the universe's current expansion rate yield different results. Is it simply a matter of measurement errors? Or is there something truly strange happening in the cosmos? So far, Webb's data indicates that the Hubble tension is not due to measurement inaccuracies. By precisely distinguishing pulsating stars in crowded fields and even discovering a distant, gravitationally lensed supernova whose image appeared at 3 different times during its explosion, Webb is providing independent checks on these crucial measurements, suggesting this cosmic puzzle is very real. Beyond galaxies, the Webb telescope's extraordinary infrared vision has also unveiled surprisingly rich and varied atmospheres on gas giants orbiting distant stars. While the Hubble Space Telescope made the first detection of gases on an exoplanet, Webb has taken these studies to an entirely new level. It's revealed a chemical cocktail including hydrogen sulfide, ammonia, carbon dioxide, methane, and sulfur dioxide, none of which had been clearly detected in an atmosphere outside our solar system before. Webb has even examined the exotic climates of these gas giants, detecting flakes of silica snow in the skies of one searing hot world and measuring temperature and cloud differences across others. The telescope's exceptional ability to measure subtle changes in infrared light makes it possible to even analyze the thin layers of gas around smaller, rocky planets. Webb has already ruled out significant atmospheres on some rocky worlds and found tantalizing signs of carbon monoxide or carbon dioxide on 55 Cancri E, a lava world orbiting a sun-like star. These findings are laying crucial groundwork for NASA's future Habitable Worlds Observatory, which will be designed to directly image and search for life on Earth-like planets. Webb has also mapped intricate galaxy structures with unprecedented detail, showing us cosmic cities where stars form, live, die, and are recycled into the next generation. Its infrared eyes reveal delicate filaments of dust tracing spiral arms, ancient star clusters forming galactic cores, newly forming stars still hidden in glowing cocoons of dust and gas, and clusters of hot, young stars carving enormous cavities within the dust. It's truly helping us understand how stellar winds and explosions actively reshape their galactic homes. In other observations, Webb has spotted hundreds of objects resembling brown dwarfs in the Milky Way, and even some candidates in a neighboring galaxy. Brown dwarfs form like stars, but aren't massive enough to fuse hydrogen. Some of these objects are so small, just a few times the mass of Jupiter, that it's hard to tell if they're free-floating gas giant planets or something else entirely. Thanks to Webb, we now know there's a continuous spectrum of objects ranging from planets to brown dwarfs to full-fledged stars. The telescope has also found potential planets orbiting white dwarfs, hinting that it might be possible for worlds to survive the dramatic death of their host stars. Closer to home, Webb has turned its gaze to our own solar system with equally impressive results. It observed the vast water plume erupting from Saturn's moon Enceladus, revealing its true scale as a cloud spanning over 6,000 miles, about 20 times wider than Enceladus itself. This water then spreads out into a donut-shaped torus encircling Saturn, even raining down onto the planet. These unique observations of rings, auroras, clouds, winds, ices, and gases are helping us better understand what our cosmic neighborhood is made of and how it has changed over time. Finally, Webb has also played a crucial role in supporting asteroid defense missions. In 2024, when an asteroid was discovered with a preliminary chance of hitting Earth, Webb was uniquely able to measure the object, which turned out to be the size of a 15-story building, helping assess the hazard. While that particular asteroid is no longer a threat, the study demonstrated Webb's capabilities. The telescope also provided vital support for NASA's Double Asteroid Redirection Test, or DART mission, which deliberately impacted the Didymos binary asteroid system. Both Webb and Hubble observed the impact, confirming that the composition of these asteroids is typical of those that could threaten Earth. In just 3 years, Webb has brought the distant universe into sharp focus, revealed unexpectedly bright and numerous galaxies, unveiled new stars in their dusty cocoons, and studied weather on exoplanets. This is only the beginning, as engineers estimate Webb has enough fuel to continue observing for at least 20 more years, promising many more cosmic surprises to come. Finally, today, in a truly unexpected turn of events, Japanese meteorological satellites, the Himawari 8 and 9, which are typically used for monitoring Earth's global weather patterns, are now providing incredibly valuable insights into Venus's atmosphere. These satellites, launched in 2014 and 2016 by the Japan Meteorological Agency, are equipped with multispectral advanced Himawari imagers. In a recent study led by the University of Tokyo, infrared images from these satellites captured changes in Venus's atmosphere, revealing previously unseen temperature patterns in its cloud tops. This is a significant development because meteorological satellites can complement observations of Venus's atmosphere, which usually come from robotic missions and ground-based telescopes. Scientists have been studying Venus's atmosphere for decades to understand the dynamics of our solar system's hottest planet. However, many mysteries persist, such as its thermal tides and planetary-scale waves. Dedicated robotic probes have often been limited to single-band imagery or short observation periods. That's where the Himawari satellites come in. Because these satellites are scheduled to remain operational for more than a decade, they offer an unprecedented opportunity for long-term, multi-band monitoring. Their instruments provide infrared coverage that measures Venus's temperature across different bands, showing temporal variations. When these geostationary satellites align with Earth and Venus, they can obtain images of Venus's turbulent atmosphere, helping to fill crucial observational gaps. The team behind the study used hundreds of images from Himawari 8 and 9 to map the temporal dynamics and track temperature variations in Venus's cloud tops over time. Their analysis confirmed that both the thermal tides and planetary waves in Venus's atmosphere are subject to changes in amplitude over time, which decrease with altitude. This novel approach opens new avenues for long-term and multi-band monitoring of other solar system bodies, including the Moon and Mercury. By providing continuous data that dedicated missions might miss due to their shorter lifespans, these Earth-focused satellites are unexpectedly contributing to our broader understanding of planetary evolution. That's all for this episode of Astronomy Daily. I'm Anna, and I hope you enjoyed our journey through the latest in space and astronomy news. Thank you for tuning in. If you want to catch up on all the latest space and astronomy news with our constantly updating newsfeed or listen to all our back episodes, be sure to visit our website at astronomydaily.io. You can also stay connected with us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, Tumblr, and TikTok for daily updates and more cosmic content. Until next time, keep looking up and stay curious.